Hello friends, this is Dr. Antoine, Doctor in International Entrepreneurship, General Manager of Air Consult Company, a company which is specialized in data analysis, auditing, taxation, accounting, strategic planning, and making models. In this video, I'm going to show you another test that you can use when you want to test the independence of categorical data or nominal data, which is called ChiSquare Test of independence. We are going to work on categorical data where we have a nominal or categorical variables. Now, as you see here, we have categorical or nominal variables, and we want to test whether there is independence or whether there is a relationship between those variables. Now, as you can see here, friends, this comment allows me to indicate where our data are saved, where data are saved, this comment. Now I execute this comment. Now here I can just import my data. This is the command used to import our data, and this command allows me to see the first element. Here we want to see whether we want to test whether our data were correctly imported in R, and I want to see first 10 elements. As you can see here, we have 10 elements. As I told you, this is gender, and this is the service. And as you see here, all are character or are nominal. This means the first observation is a man and is affected in production. The second is a man and is working in production, and so on. But I can show you my data, whole data, and you can have idea of what it means, categorical data or nominal data. Now, as you can see here, this is my data frame or data set. I want to know whether there is relationship or there is independence of gender and service. In other words, I want to know whether being man determines whether we work in production or in other service. One variable, the woman, production. Here you see men, here contability or accountants, and so on. Now I can make a table so as to count how many are in production, how many men are in production, how many women are in production, for instance. And this command here allows me to make a table of our data. Look, friends, now I can just use this command. This one can also help me to print the result, but the command is this one. When you want to print the result of your analysis, use this command. I can only delete this command. It is not. Okay, friends, this is the table I make. I want just to calculate how many men are in each service and how many women are in each service. It is this command table which will help me to calculate the number of, or to count the number of women and the women by service. This command allows me this. When I execute this command, I run here, I finish to count. Now I want to visualize the results. I want to visualize the results saved in this name. I like this command print. I make run. Now, as you can see, now we have a number by man, by gender, and by service. Here, for example, contability or accountant, we have 20 men and 8 women. Here in the marketing department, service, sorry, we have, for instance, 20 men and 30 women, and so on. Now I can calculate proportion of this in terms of, in place of having numbers, I can calculate proportion, and it is this comment that I'm going to use to calculate the proportion, this comment. Okay, now you see, now here, men which are men who are in contability represent 10%, women who are working in contability represent 4%, and so on. With men who are in marketing service are 10%, women who are working in marketing department are 15%, and so on and so on. This test evaluates the extent to which there is a significant association between the categories of two variables. And the null hypothesis is that there is no relationship between gender and service in our case, but you can replace this by your data. And the alternative is that there is no relationship between gender and service. Now our significance level is 5%. That means when the p-value is greater than 5%, the independence test is not rejected. But that means we fail to find evidence that there is a dependence. Now we agree, and we agree with the independence if the p-value is greater than 5%. When, on the other hand, when the p-value is less than 5%, in that case we will reject the null hypothesis and say that there is a relationship between service and women. But when we don't reject the null hypothesis, that means there is no relationship, there is independence of service and men. In otherwise, being men does not predict the fact that you will be working in service, accountability, or production. That's what it means. Now this is the comment to learn this test, independence test. You see, this is the comment, and this will be applied to our table. This table, when we count when we count the number of men and women by service, this table, this one, the comment will be applied on this table. Now let's learn and see the results. Here I want just to print the result, the p-value. Now as you can see here, friends, the p-value is less than 5%. Now we say that we reject the null hypothesis of independence, and we say that there is a relationship between service and gender. That is what it means here. And we can also go to make further analysis, and you can test to which extent there is such a relation. In that case, we use a test of correlation called Cramer V, this one, and it will examine or calculate coefficient of correlation between gender and services. Let's show, but you have to install this package, this package. If you don't have this package, you have to install it. And when you want to install a package, look, friends, when you are working and you found that you don't have this package, you come here, friends. Here you see packages here. I don't know if you see here packages, sorry, packages, and you come here, install, like this, friends. You come here, you install, and you write the name of this package. For instance, you write like this. Normally when you write a name of a package, it will appear here, and then after this you make install. But I'm not going to install because I have already installed this package. Okay, now friends, when I run this command, so this command, I execute this to call. I am just calling this library in my working environment because I'm working now, but I have to call this package in my working environment so as to help me to execute this command. Now I just calculate the correlation between gender and service. In my case, Now I just need, when you want to calculate the correlation coefficient of gender and service, you have to install this command first, and then you are going to use this comment. Look friends, I just learned this is the correlation coefficient of gender and service, and we conclude that there is the relationship between gender and service. There is no independence. But the problem is, if they were independent, what is the number of observations we would have? If they were independent, how many women and how many men we would have in each service? This is what we are going to see, what we call expected observations. This comment allows you to show the actual observations, this comment, and this comment expected allows me to show what we would have if they were independent. Look friends, look this is the result of what we would have if they were independent. Look, in contability we have 20 men instead of 16 men if they were independent. Women, in the same service, contability, we have 8 women instead of having 12. Let's say 12 or 12, because there is no semi employee. And in marketing, currently we have 20. Currently we have 20 men. But if they were independent, we would have 29 men in marketing. We have 30 women in marketing instead of having 21 if they were independent. Now that is how you can use this test, friends. And okay friends, now as you can see here, now this is my presentation, and I think this can help you to increase. And as example, you will see here these comments. It is just a way of applying what you have learned. And this is a data frame which is in this library. If you don't have this library, you have to install it. And this library will help me to select some variable. And you can see I'm just calling this data, and I just save my data in data. I just want to see what kind of data I have in this command, and you see we have so many, but I'm interested in gender here. Gender, you see gender here, this is gender, sex, and OKIP here, OKIP. Let me see what we have in OKIP. In OKIP, you look friends, OKIP we have this variable. We have exercise in profession, we TD, LF, and so on. You see here we have a nominal data, but you can also denoted. I can just also test whether denoted there is any relationship between denoted and sex. Now what you can just do is just to select some variable here. I selected from my data sex or gender and OKIP, and I want to find whether there is relationship or there is independence of sex and OKIP. Look friends, I just selected this, and I make a table, and I execute around this command like this, and print test, and I print the result like this. Here friends, also you see the p-value is less than 5%, and you conclude that there is relationship. There is no independence, but there is relationship between OKIP, this variable OKIP, and gender. I can also use test. Let's show you, for instance, I can just select another command. Look, for instance, I want to test whether, look, I do like tests, and I do what table. Let's, for instance, do like this. I want to see my data. I want to test the relationship between niveau d'étude and, for instance, data. What is another qualification or diploma? This is, I want to see if there is an independence between niveau d'étude and the qualification. For instance, or those are categorical data or nominal data. And you see also here, as you can see here, there is the independence test, the independence, the null hypothesis of independence was rejected, and you conclude that there is a relationship between niveau étude and qualification. Okay, friends. Now, in summary, this test, ChiSquare test, is used both to examine to which extent two categorical variables are related. If the p-value is less than 5%, you reject the null hypothesis, and if the p-value is greater than 5%, you do not reject the null hypothesis and conclude that there is independence, there is no relationship between your categorical or nominal variable you are analyzing. Okay, friends, this is the end of my presentation. If you found this video helpful, you can just like it and share it, and you can also subscribe to my channel, and I will continue to share with you some tests, some statistical analysis that can help you to increase your knowledge in data analysis. And thank you for watching my video. Bye.